we are going to discuss about an evaluation of gas consumption prediction on Ethereum based on transaction history summarization. Now we are going to see about the overview of our project, that is the abstract. The main objective of our project is to forecast or to predict the gas consumption and gas usage prediction. The system uses data about transactions on Ethereum as sources for studying the relationship between the historic of transactions for a given address and the amount of gas consumed for a transaction. The system combines data about transactions and block to predict the gas usage for a transaction. Then the result demonstrates the value of considering the transaction history for gas usage predictions. Transaction history summarization is used to predict the amount of gas used by transaction for a given address. The system is developed the two different machine learning algorithms such as lasso regression and random forest. Finally, the experimental result shows that the accuracy R2 square, ROC curve and confusion matrix. Then we have to predict the gas consumption based on gas transaction and recipient gas consumption. So this is the overview of our project. This is the flow of our project. Ethereum dataset. The dataset was collected from dataset repository like Kaggle, UCI or GitHub. Then we have to take the input data. The input data, after collecting your dataset, we are load or read your input dataset by using pandas package. The input data are carried out to pre-processing step. So here we have to check missing values in your dataset. Have any missing values means we have to replace that missing values by zeros for avoid wrong prediction. Then label encoding. So the label encoding means we have to convert the string into numeric integer value. Then drop unwanted column. If dataset contains any unnecessary columns or unwanted columns for our project, for our process, means in priorly we are removing or drop that unnecessary columns. Then data splitting module. The pre-processed data are carried out to this module. So here we are splitted the whole dataset into test and train. Test is used for prediction and train is used for evaluation. Based on ratio, we are splitted our dataset. The splitted data are carried out to classification module. Here we are implemented different machine learning algorithm. One is lasso regression, other one is random forest. So with the help of this, we have to classify and predict the gas consumption. Finally, we are estimated some performance metrics like accuracy, ROC, then confusion matrix. Accuracy means it is a overall prediction, how our model predict accurately in terms of percentage. This is the flow of our project. Now we are going to see about the demo of our project. We are running our project in Spider IDE from Anaconda Navigated. So this is the data selection. So here we are displayed some sample of data from your data set. Then we are checking missing values. So the 0 means there is a no missing values is present in our data set. So this is the they have these number of missing values is present in corresponding columns. After handling missing values, first we have to remove missing values in here. So 0. Then remove missing values in this column, so also contain 0. So for avoid wrong prediction, we are checking missing values. If you have any missing values, means we have to replace that missing values. Then data splitting. So here we have to split your whole data set into test and train. So this is the total number of data which is present in our data set. After splitting, so this is the total number of test data, this is the total number of trained data. Then performance analysis for lasso regression. Then this is the performance for random forest or OC curve, confusion matrix. Then prediction. So the blue indicates the gas transaction prediction, then the red indicates the gas consumption. So this is the prediction for gas consumption and gas transactions graph. Thank you.